Okay, so what I'm going to do is I'm going to go through a couple of problems like the ones that are assigned for homework. And then there are a few items I need to cover that were not covered in the previous video. So the first group of problems just asks you which quadrant a certain angle is in. So let's just review that. Quadrants, we didn't talk specifically about that. So here we go from 0 angle. Here we have pi over 2, which is 90 degrees. That's the radians. So this is pi over 2, or 90 degrees. Here we have 180 degrees, or pi. We have 270 degrees, or 3 pi divided by 2. And we have 0 and 0, 0 degrees and 0 radians. It's also going to be equal to 360 degrees and 2 pi radians. So to figure out which quadrant something's in, all you have to figure out is where they are relative to these values. So let's say if I give you an angle, theta is equal to 7 pi over 5. So all you have to do is see where that fits in here. This is 1 pi, this is 0.5, this is 1.5. So if we take 7 and divide by 5, we'll get 1.4. So 1.4 pi. So you can see that's between 1 pi and this is 1.5 pi. So this one is going to be in the third quadrant because it's between pi and 1.5 pi. If we just take a decimal number instead, let's say theta is 3.5 radians, and these are all radians. So 3.5. So the question is, what the heck do these represent? You can also do it in terms of decimals. So pi is 3.14. So approximately pi over 2 is going to be half of that, which is 1.57. Then if you take 1.5 times pi, you'll get 4.71, and 2 pi is going to be 6.24, 3.14 times 2. So again, all you have to do is look at this number and see where it fits. So you got 3.14, 4.71, so 3.5 is between here and here, which is in this quadrant. So this is also Q3. Let's just do one more. So let's say we have a negative. So let's say it's negative pi over 12. So that's going to be negative 1/12 pi. So 1 divided by 12 is 0.083, a negative sign. So, these are all based on going positive direction. Now if you go the other direction, this position relative to the positive x-axis is going to be negative 90 degrees. This will be negative 180 degrees. This will be negative 270 degrees. Likewise, this will be a negative pi over 2. This will be negative pi. This would be negative 3 pi over 2. And if you go all the way to the b, you'd have negative 2 pi. So from a negative perspective, you see here we have negative 0.083. So we have negative, where is it here? Yeah. So pi over 2 was 1.57, so this is a negative 1.57. So because we're between 0 and negative 1.57, then this one ends up being in the fourth quadrant. So that's kind of how those problems work. Okay, the next group just says sketch the angle in standard position. So I have assigned 14. I've assigned well, you don't really know because I'm making up the homework. So let me just give you an example. So 5 pi over 4, and we'll also do negative 2 pi over 3. So to do something in standard position, we have to draw our coordinate axis. And remember, this is pi, oops, don't do that. This is pi over 2, or negative 3 pi over 2. This one is positive pi or negative pi. This one is 3 pi over 2 or negative pi over 2. So those are the positive and negative versions. So here we have 5 pi over 4. So remember that one part of the angle goes in the positive x direction. 5 pi over 4, well, that's 5/4 is greater than 1. So if we go pi over 2 pi, it's going to be in this direction. And if you think about 1 and 3/2, 5/2 is right in the middle. So the angle 5 pi over 4 is going to look like that. So this is pi over 2 pi, and then 1/4 of the way is 5 pi over 4. Okay, now the next one, we're going to go negative 2 pi over 3. So that's 2/3, which is 0.66. Here we have negative 1/2 pi over 1/2 pi. So that's going to go similar kind of deal. You're going to, instead of going this way, you're going to go this way. So that's 1/2 a pi, and we got 2/3. Now if we went to here, that would be 3/4, and that would be a full thing. So you got full pi, negative pi, negative 3/4 pi, negative pi. So 2/3 is going to be like that direction. And you're measuring not counterclockwise, but clockwise. So that angle is negative 2 pi over 3. So that's kind of how you work those problems out. Think about what these coordinate directions are: positive x, positive y, negative x, negative y. Where do these numbers fit in to that sequence? Okay. Then what we have is we have measuring or representing angles as multiples of pi. So all you have to do there is, let's say you have 30 degrees, and we want to represent that as some multiple of pi. Now, if you think about it, here's 30 degrees over here. 30 degrees. So it's got to be somewhere between 1/2 pi and 0 pi. So the best thing to do is you use the conversion from degrees to radians. So you got 30 degrees times, the conversion is pi divided by 180 degrees. So all we have to do is we don't multiply by pi, we leave the pi there, and then we just take the ratio of the two angle measurements. So 30 divided by 180, if you simplify that fraction, it's 1/6. So we get 1/6 pi, or pi over 6. So the equivalent of 30 degrees in radians is pi over 6. Let's do 195 degrees. No, that's not what I want to do. 210 degrees. So you do the same thing. 210 degrees times the conversion factor, pi over 180. So what we do is we take the ratio of these two angle measurements and we multiply that by pi. And again, you can simplify this. They have a common multiple of 30. So 21 divided by 30 is 7. and 180 divided by 30 is 6. So you get 7/6 pi, or 7 pi over 6. So the equivalent of 210 degrees is 7 pi over 6. 7/6 is greater than 1, so it's going to put me over here. 210 is greater than 180, so it puts me in the same relative position. So if we wanted to just do the direct conversion from degrees to radians, we would put in 3.14156 for pi. But a lot of times we want to do it in terms of these angles as a multiple of pi. Okay, now if we want to convert angles to, well, this usually works for things like 30, 45, 60, 90, all these multiples, specific multiples of 30 and 45. But a lot of times if you're given a angle that's not one of those easy ones, let's say you have negative minus 223.7 degrees, and you want to convert that to radians, all you do is you multiply by pi and divide by 180 degrees. And in this case, you want to use the actual decimal value, 3.14159, or if you have a calculator that has pi on it, which you should if you're taking trigonometry. So you're going to have 223.7 times 3.14159, or pi, divided by 180, and you get negative 3.905 radians. Now if this has 4 digits, you want to have that as 4 digits as well. So that's pretty simple. If I did it as some fraction of pi, I'd have 223.7 divided by 180, which is not any kind of normal simple fraction. So there's no point in doing that here. Okay, and then you can convert from radians to degrees. So the radians could be in a decimal form, or they could be in a percentage of pi. So I'm going to say what is 7 pi over 5. So in that case, so we can use a calculator, we don't use a calculator. So let's do two kinds. This one you're going to have to use a calculator just because 7/5 is not one of the angles. So this is a case where you would use a calculator. So all you do here is you're converting from radians to degrees. So you take 180 and you divide by 2 pi, and then you just plug those in. You can see the pi stuff cancels out. So you could almost do this without a calculator. You just take 180 times 7 divided by 5 divided by 2, and I get 126 degrees. So yeah, I guess as long as these are rational expressions, some rational expression times pi. If it was something like 2.7 radians, what you would do there is you'd multiply by 180 divided by 2 pi, but you'd plug in the value for pi, so you'd have 2.7 times 180 divided by 2. Oh, actually we're not. Yeah, I made a mistake here. So this should not be 2. It should just be 180 divided by pi. Okay, so let's fix that. So 7 times 180 divided by 5. Should have realized that. 7 times 180 divided by 5. So I get 252 degrees. Okay, now here it's not some rational number or just a rational expression. It's just a decimal expression. So in this case, I just take 2.7 times 180 divided by pi, which is 3.14159, and I get 154.9 7 degrees. So that's now if you have something more like this, if I have 7 pi over 6, so if the denominator is 2, 3, 4, 6, then if we wanted to convert this, we would again use 180 over pi. The pi's cancel out, and then we could rearrange these, so instead of dividing 7 by 6, we can divide 180 by 6, and 180 divided by 6 is going to be 30, and then 7 times 30 is 210. So that's another way of doing it, especially if it's something other than, if it's if the denominator is 2, 3, 4, 6, possibly even 12. That's because 180 is divisible by those numbers easily. It actually turns out that 180 is divisible by 5 as well, so that's why that one works out as well. But if it was 9/7 or something like that, let's say we have 9/7 times 180, 9/7 pi times 180 over pi. The pi's cancel out, but 180 is not divisible by 7, so you're going to end up with a rational number that's not nice. It's going to be 231.4285714. If you go far enough, you'd start to see this thing repeat, because it is a rational number, but it's got a lot of decimals to it. Whereas if it has a denominator of 2, 3, 4, 6, 12, then, or any factor of 180. So what are the factors of 180? Let's just write those out so we can think about it. So the factors of 180 are going to be 1, 180, 2, and 90, 3, and 60, 4, and 180 divided by 4 is 45, 5, and 180 divided by 5 is 36, 5 and 36. Then you have 6 and 30. How about 8? 180 divided by 8. No, that's 22 and a half, so that's not any good. 180 divided by 9, that's 20, so you got 9 and 20. You've got 10 and 18. And then you've got 12. 180 divided by 12 is 15. So you got 12 and 15. So let me write all this stuff out. So you got 1, 2, 3, 4, 5, 6, 9, 10, 12, 15, 18, 15, 18, 30, 36, 45, 60, 90, 180. So if the denominator is any one of those things, then you can make it as a percentage. They'll come out to actually degrees. Let's just try one of those that we're not used to. Let's say you had 3. Let's want to use 5. I keep picking ones that are multiples of, that I could simplify the fraction. So I was trying to find one that you can't simplify. So we could go to 7, because we have 2, 3, 4, 5, 6, 7. So 7 over 45 pi radians. So what is that going to be equal to? So you take 7 divided by 45 times 180 divided by pi. But 180 divided by 45, that's going to be, let's divide that. 180 divided by 45 is 4. So you have 7 over pi times 180 over 45. But 180 over 45 is 4. Oh, yeah, what we were doing here, this is 7 pi over 45. So those cancel out. So if you simplify this, you'll get, this is 4, so you get 28 degrees. So 28 degrees is 7 pi over 45. Okay. Okay. So let's just do 2 more here before I give you a little more lecture on this particular subject. So, we looked at the quadrant relative to radian degrees. Let's look at another one. So let's say we have 8.3 degrees or 257.30 degrees. So we want to know what quadrant those are in. So again, you draw your axes. You'd say, in terms of angles, you'd have 0, 90, 180, 270, and then back here to 360. So 8 degrees is going to be somewhere in here. So you can see that's quadrant 1, and the second case is 257. So here's 270, here's 180, so 257 is going to be somewhere like that. And so this one is quadrant 3. So as long as you know these angles that separate the different quadrants, you just have to determine where that fits in. And as far as drawing angles in their standard position, the same thing applies. As long as you, if you're given an angle and you have to figure out where it points sketch-wise. So here's 0, here's 90, here's 180, here's 270. So if I gave you negative 270 degrees or positive 120 degrees. So here we have negative 270. So if this is positive 90, this is negative 90. This is negative 180. This is negative 270. So if I go negative 270, I'm going to be pointing up here. So this one, there is no quadrant. So if you're pointing in the direction of the axes, we would say none. What quadrant is it in? We could say none, or it's between. We could say between quadrant 1 and quadrant 2. Here's 120, so here's 90, 180. So this halfway between 90 and 180 would be 135. So it's got to be on this side. And if you think about it, 120 is 30 more than 90. So if you go 30, that's 120, 30, 150, 30, 180. So it's a third of the way around. So that would be 120. And because it's pointing up here, that's quadrant 2. So this would be Q2. So that's how those problems work.